Hi, I'm Jay Beale, and I'm here. I'm here. I'm going to talk to you about Kubernetes attack and defense. I like to do capture the flag style exercises, and I do that honestly partly because it makes all this stuff more interesting. It gives us ties in some story, and also I do it because I try my hardest to take any of the kind of demos I do and make them into exercises that other people can do. And so I put them into a Kubernetes cluster that you can download called Bustakube. So, or Bustakube. Who knows what the proper pronunciation is around here? Um, yeah, sorry, I'm feeling a little nervous because I can't see any of you, and this is actually a really new experience for me, like having having doing a lot of virtual. And But yeah, I hope that you have a good time. I hope you learn some stuff. I hope eventually, out of this I learn some stuff. I know I tend to. So cool. So let's see. First up, I've got a bio. I've stopped doing the text bio, and I've started doing a graphical bio because nobody reads the text. It all just kind of blurs on the page. So this is stuff that I do or enjoy or have done in the past. So a couple of the ones you'll be hearing about today are Paratis and Bustakube, a couple open source projects I work on. So cool. Let's see. So what are we going to do? What are we going to do today? I'm going to basically walk you through an attack on a Kubernetes cluster. And I've themed this on the movie Inception, which, whoa, was a lot harder than I thought. So if you don't remember that movie, because it's been a long time, don't worry. Whatever minor amount of plot you need to know, I'll catch you up. The big deal basically is, over the course of the movie, dream within a dream within a dream within a dream. So I think I'll try to speak to that plot in just a second. So what are we going to see? The attack path we're going to look at basically has, I start out, you always, attacking Kubernetes, you rarely have this like amazing luck where somebody's just happened to expose a Kubernetes dashboard out of the internet the way Tesla did, to make it easy to do crypto mining, make it easy to get a whole bunch of their resources involved in crypto mining for you. So most of the time, an attack on a Kubernetes cluster starts out from inside it in some way. So some kind of assumed breach. The premise I've taken here is, because around the time that I was proposing in the talk, there was a lot of news about library. Man, apparently I'm either nervous or sleepy. I'm not sure which. So apparently, since there was a lot of news at the time about typo squatting on libraries. One of the big ones was something called Colorize, where if there's the kind of let's just call it U.S. English spelling and maybe proper English spelling. I'm not sure, but where you add a U, and if you the library uses one of those two, but the attackers typo squatted on the other one, and what that got them was into people's workloads, into people's programs. So I'm going to talk about that. I'm going to talk about a monkey in the middle attack on a service in Kubernetes. We'll use that for fun. I'll show you a public cloud API attack, and pod security policy evasion. And then on the defense side, we'll talk about software supply chain. We'll talk about namespace isolation and what you'd want there. I'm really excited that we're about to start getting nested namespaces. We'll talk about workload identity and also OPA Gatekeeper, one of the admission controllers that's competing with pod security policies and K-Rail and whatever else people are making. So let's see. So we're going to go right into demo, and that's where we're going to honestly spend the bulk of our time here. I've made a demo video, And since I type a little slow, I'm going to try to kick up the speed, and we'll see how that works out. My demo video is all typing. There's precious little graphics, but this is probably a good time for me to just remind you about the plot of the movie Inception. So in Inception, you've got Leonardo DiCaprio and his team, and they are trying to win by basically affecting somebody's dreams, or bringing somebody into a dream, and then doing that at multiple layers. So they put the person under sedation and bring them into one dream, and then within that dream, they put them under sedation again and into another dream, and then another one, and then another one. And the movie is kind of interesting and fun. But I thought it would be really neat because with Kubernetes we talk about we're containers and what's a container and so on. So it just seemed like a good theme to play with. So let's go and do the video thing. So I've practiced this. Let me just do my screen share, and boom. Okay, cool. So what I've done is I'm basically I'm asking you to stipulate to the idea that we can do. Sorry, I'm asking you to stipulate that we could basically typo squat on a library or on source code and end up in somebody's program. And I want to show you what that can look like. So here we go. I'm going to start out. We've got I just want to kind of talk about the news that got me thinking here. The Python, and actually this wasn't my thought. This was a friend of mine's thought, Ava Black, who was very, very interested in the fact that that PyPy doesn't use signatures, and that there's actually a whole ton of work to be done in supply chain and software, in secure software supply chain, because we all download things. I certainly will build things. I certainly will build my images by starting with a from on Docker Hub, and in the early days, that from would be whatever was useful. It wasn't always one of 3 or 4 things that I absolutely positively knew. So here's a couple things that happened that were discovered at exactly the same time. Typo squatting, where attackers basically said, wait, date utils used a ton. Everyone's making the move to Python 3. Let's go and register Python 3 date util on the PyPy, on the Python package index, and do some stuff. And the other one they did was a modification on Jellyfish, where they were changing an L to a lowercase L to a 1. So anyway, these were two clones that were found, and it turned out that date util, which was probably far more popular, was only had the typo squatting going on for 2 days, but the Jellyfish library had been like that for like a year. And what the attackers got out of it was PGP keys and SSH keys. And the way that works is kind of like what you're going to see here. As an attacker, you go and say, okay, someone's trying to get that library. They're going to be importing it. They might be importing it on every single build, or they might be doing it on some less regular basis. But they're going to be pulling it down And if I can make it so that they pull down my software, all I got to do is make sure as an attacker that my software does the same thing as the thing that they're expecting, so that they don't notice it. But then also add some step. And so that step could be, anything that you would do with a Trojan horse. It might be to, grab whatever PGP keys or SSH keys are in a home directory and ship them off by some C2 mechanism as fast as you can. I'm going to stipulate that one of them might be to leave code running in a cluster and send back a Metasploit interpreter binary. So that's what we're going to do. What I've done is created and this is, I'm going to have little pictures show up from the movie to kind of show you where you are in the stages of this gentleman in the front being taken advantage of, I guess. So what I'm doing with the software supply chain issue here is basically saying, if somebody were to happen to, if somebody were to end up with my code in their container that they were staging to a Kubernetes cluster, this is where we go. And what I made my code do is I just took one of the actual images that I was using, and I added something to it. I added 2 lines to a Docker file. One was to copy an interpreter binary in, and the other was to start it running before running the real program that's supposed to be running in that container. So this container, when it starts, will start up, and as soon as it starts up, it will phone home. And this is just an interpreter reverse shell binary. It connects back to me on HTTPS. Wait, I don't know that it connects back on HTTPS. What am I saying? That's what I would love to do with web shells, but but interpreters are not known for being anywhere near that careful. So I've got an interpreter. It's going to start, and it's going to connect back to me. And I've staged a copy of Metasploit actually in Docker. If you think you have to download Kali to get Metasploit going, it turns out it's way easier than that. There's a Docker image for that, which is also a great way of getting Metasploit into a Kubernetes cluster. So I've got Metasploit here, and I've been practicing with this a bunch. So you're seeing session number 11. But as soon as I should do this in another window, I guess. But as soon as somebody applies that image, starts up that pod in their cluster, that the pod that's using this container image is running my interpreter. And so I'm going to end up in a pod in the cluster. And so this is kind of standard fare. I'm going to interact with the interpreter and find myself in a pod. And this pod's called supply chain, just to kind of make the point. And so I now basically have a shell that's going to renew nicely out of Metasploit. So I do a little bit of quick little, pen tester, give myself a nicer PTY, and now I just start seeing what's the lay of the land. So I won't have the normal environment variables to tell me what the API server's IP address is, but nicely I have kubedns to or core DNS to give me my API server by name. I'll use the token that's auto mounted into the pod. By the way, that would be a great way to give attackers a lot less capability, is just say which pods do you have that actually need to have a service count token mounted in, and for all the rest, don't. And so I found myself in this cluster, and this cluster's looks like 3 pods running. They all look like they were nicely put here by deployments. So they've got kind of, replica set numbers and all that. And I've done my get pods to get a list of what's running in here. The supply chain one has been only around for 36 seconds because that's how I just got in here. And like a diligent attacker, I was waiting for this connection to come in. So very first thing I do is just make things easy on myself by taking those command line flags I needed for kube control and make them into an alias. So now I'll say, let's get services. And okay, see some services, CheckPosition, Venerable Kubernetes, and then Robert Fisher. And let's get a list of secrets. And I see, oh, there's a flag. I'm not actually going to be able to read the value of the flag, but I don't need to. This flag says, okay, here's your flag. Now go get Robert Fisher, trust you. And at this point in the movie, I've switched us to Robert Fisher has been, was on that plane and took the took the drink that he was offered by Leonardo DiCaprio and, started dreaming. And now he's now in a van with Leonardo DiCaprio and his team. And they're all dreaming. So now we're in that dream and entering into the next dream. And we've got our flag. Go get Robert Fisher to trust you. So how are we going to get him to trust us? Well, let's go connect to him. He's got a nice little service. Okay, so Robert Fisher, the mark here, he's basically offering a microservice. It says it answers to trust me, and you put in your last name. So Cobb is Leonardo DiCaprio's name in the movie. So we're going to see if Robert Fisher will trust Cobb. Says, nope, you're not my head of security. And in this part of the movie, Leonardo DiCaprio is trying to convince the mark, Robert Fisher, that Leonardo DiCaprio is his head of security for dreams. And he's going to, and when he does, he gets the mark to actually, fight his own security forces off. So this says that he figures out where their trust is by looking at his CheckPosition service, and that thing's never heard of us. So let's go interact with that CheckPosition service and see what it is. So CheckPosition, another nice helpful service that gives us some information. Cool, it says it's going to tell us what position somebody has. Man, even when I'm recording, I'm still going to typo. So it's going to tell us what position somebody has if you tell them the last name. So this is what Robert Fisher's service is querying. And I'm doing this because that's a very normal pattern we see in Kubernetes clusters where you have taken an app and broken it up into microservices and they query each other. So Robert Fisher is querying his CheckPosition service to find out what someone's job is and thus whether they work for him. And CheckPosition is going to say this person Leonardo DiCaprio doesn't work for you. And that's not good. We want Robert Fisher to think that Leonardo DiCaprio does. So what do? Well, if we look at the service, turns out that if you're in a namespace, if you can stage your pods in the same namespace as somebody else or something else, and you'd like the traffic that's going to come to it from services, Kubernetes internal load balancers, all you've got to do is, all we got to do in this case is basically have the same labels that thing has. So if we can look at the service, we can figure out what those labels are. If we can look at the pod that's supposed to get the traffic, we can find out what those labels are. Or honestly, we could automate that and create a ton of labels, and we can figure that out based on what we find on GitHub. So I've created a little monkey in the middle pod, and I'm going to upload it from my Kali system. Come on, Jay, type a little faster. And once I've uploaded it, I'm going to interact, and I'm going to see if I can stage that. And so it turns out that my account, I've skipped all of the querying of auth can I and so on. And my account is actually allowed to stage things, is actually allowed to stage pods. So I've created a man in the middle, and my man in the middle basically is going to always answer that whoever the person is that you're asking about is your head of security. So as long as I set my labels to the same thing as in that selector on the service, then I'm going to get some of the traffic. Now, there's one legitimate position checker pod and one of my man in the middle pod, monkey in the middle pods. So I'll get half the traffic in general. If I want, what I really should do, since I'm lightweight anyway, is stage up 100, because then I'll get the traffic 100 out of 101 times. So once I've staged up this monkey in the middle pod, if I curl that CheckPosition the way that Robert Fisher will, if I curl it enough times, I'll start getting the monkey in the middle pod that'll say security head. So, and I'm going to do that, and I do that now with Robert Fisher. I query Robert Fisher. Robert Fisher queries the service. The service sometimes goes to the real place, sometimes goes to my monkey in the middle pod. And once it goes to my monkey in the middle pod once, I get what I'm looking for. So this thing, now Robert Fisher says, I trust you. I know my uncle is actually the bad guy and we need to invade my uncle's dreams, so I'm willing to go, into another level of dreaming. And which means in this case, get root on one of the nodes of the Kubernetes cluster. So nicely, Robert Fisher gives us the service account token, kind of similar to shooting his own guards. And so this is the point where he's decided he trusts us. So we're going to echo that. I'm going to write that token to a file, and now I'm going to start using that token instead of the one I normally had. And I'm going to see if I can upload an attack pod. I'm going to see if maybe Robert Fisher is allowed to stage pods that can mount the host file system on the node. And turns out Robert Fisher isn't. There's a pod security policy in place that says that Robert Fisher also can't launch pods that mount the host file system. So everything's safe, right? Well, it's we're going to find out that there's a slight. It's not kind of a vulnerability. It's more works as intended, but not as expected kind of thing. So this is something that the Trail of Bits folks found on the Kubernetes security audit. So I'm basically going to create a deployment. I'm going to deploy a pod, and this pod is going to mount a volume, but that volume is going to be from the node's file system. And the reason that's going to work is it turns out there's another way of mounting the host's file system. There might be more, but at the very least, you can use persistent volume claims and set the storage class to manual. And then if you're allowed to create your own persistent volumes and your own persistent volume claims, then that's the works as intended. Then unfortunately, that's not as safe as it should be. You basically get to do the same thing the pod security policy was trying to stop here. So if we're allowed to stage this, and we're going to stipulate that Robert Fisher's account could, or we're going to see that Robert Fisher's account could, then I'm able to get my pod in that's called I've called attack PVC, is persistent volume claim. And so something else I've done is I've built those attack persistent volume claims to have that same interpreter in them, because I'm just using the same image that I've staged as my hostile typo squatted image. So now I'm hopefully a little further along, and I'm in the node. And the interesting thing I find on the node is when I look at the host name, I find out I'm in kind. So I'm in a Kubernetes cluster that's running in Docker. But even more than that, there's a configuration file on the root file system here for something called a outer. So there's another Kubernetes cluster that this is running on. So I'm running kind, and I was able to get kind to run in kind. And then that kind to run on the cluster, but it was a little pain. So anyway, we've got kind, which means that we have a Kubernetes cluster running as a container in our Kubernetes cluster, or as a set of containers, and using the Docker and Docker style method. So at this point, what I'm going to do is use that configuration file that I found. This is kind of another flag, and I'm going to see if I can deploy something, if I can basically get out of this inner cluster by deploying a workload onto the outer cluster. So when I do that, I end up getting some more interpreters. And this is putting me in another supply chain pod, but that pod's in the outer cluster. So we should be on a new pod in the outer cluster now. And this is basically the the last place that our Mark goes. He goes to see his dead father and find out his father was not so bad. So what I want to do now is add in a cloud attack, and I'm doing this with a tool that needs your help. It's an open source tool that a few of us have worked on called Kubernetes. Kubernetes is Greek for helmsman. Kubernetes is Greek for pirates. And so this is a little tool that we've just been taking different things that we could automate that were useful in pen tests and putting them into a tool. So yeah, we did a little ASCII art logo because you have to. And I'm just going to advance this a little more. So lets you we have menu items. You can, the idea in general is you're trying to pick up service accounts and then do things with them and escalate privilege. So I'm going to do some of these. The one that I like when I can get it is if I have a COPS cluster, if I use COPS to build a cluster on GCP, it stores a whole bunch of Bootstrap service accounts in a bucket, and that bucket is readable with the default scopes in GCP. That bucket's basically readable by all the accounts that are in the project. So I do a few command lines, and we've just automated this at this point, so we can basically say, okay, let's get the default, let's get the token out of the metadata API, let's grab the project ID out of the same place, let's go looking in all the buckets, and then searching through all the buckets, let's see if we can find any service count tokens. And if we find them, then we'll automatically populate them so that when you hit this SA menu and say, I want to list my service counts, you see the one that you started with, but then you also see these ones that were acquired from GCS. So now I can go and say, I'd like to switch service accounts, and I'll put myself in the context of the admin account that I got from that. And I'll switch namespaces over to Kube system because there's much more interesting stuff in there, like control plane elements. And so I'll list the secrets that are available in that namespace. Oh, plenty of service counts, and that will basically let me keep adding to my store of service counts and exploring what I can do with that. Now I'm just going to kind of get ready to jump ahead and take over a node. But before I do, I just want to show you a couple more things. So one is we built in off menus. You can run kube control out of this. Actually, if you run Kubernetes, if you name Kubernetes kube control, it will operate as kube control because it's built on the kube control library, Golang library. So it's kind of a little kube control of its own. And then the other, we've also built curl in. Not a full curl, just we let you make GET requests and POST requests and specify custom headers like you'd need for a lot of cloud APIs. And of course, parameters, and we'll URL encode them for you. So I'm just going and I'm just doing a quick, like, here, I can get my IP address. So let's do that whole, like, go get a... Actually, I think what we'll do is we'll first run a command in all the pods. And this is only so easy because we have that admin already. So I'm just going to say I'd like to run an ID command in all the pods. So the fun here is honestly just automating it. And if you like to write Go or want to learn it, please come help, because I can't tell you how much fun I have when I do like in advance of this, make myself go and add a feature or what have you. So turns out when we look at the secrets that are available in the default namespace, we find one called flag, and we can go get that. The thing I like, the reason the kube control from inside here is interesting is that you're getting to carry all of the service counts you took with you and operate within those contexts. And we even had, for a little while, although it broke, an injection mechanism where you could inject yourself into another pod and carry all of your service counts with you. So here's that flag. It says you've gained admin on the cluster. Can you go a little further and get root on a node? So we're going to try this one. And it says, this one's really simple. It basically it starts a pod that mounts the host file system, and then edits the cron tab file and adds a netcat listener that'll launch, or a netcat outbound shell that'll get launched once a minute. So you specify a port and IP, and we'll just specify one that's in the that's right in here, that's in the pod. And I am absolutely running short on time, which is to say I'm running into somebody else's time. So I'm gonna, as soon as this demo finishes, I'm going to go and see any of you want to talk in Slack. I'm really sorry I got such a slow start, and I hope that I did not put you to sleep. So if you start a Netcat listener up, some time passes and you get to the end of the movie where the guy on the left has become as old as the guy on the right, but it's only because he's in a really, really deep dream. So anyway, let's see. So this is that host mounting where we launch a pod. We launch a pod that mounts the host file system. We use it to modify the cron tab, and then we remove the pod, and that happens automatically. And now you're some time would just pass a little faster. You're on the node, and this isn't the master. This is one of the nodes, but you could use tolerations to get yourself onto the master. And we can find our flag. So anyway, that is my demo and my apparently poorly timed talk. So thank you. I hope that you enjoyed it. And I'm going to stop sharing my screen. And I will see you in Slack. And I'll be happy to learn from you and see what I learn. Cool. Thank you very much.